Hey guys, the Wood Craftsman here. So I thought it'd be a really good time right now to actually talk briefly about compressed air systems in the shop. I get quite a few questions periodically when I do a finishing video. People see me blowing the dust off the parts and never see me actually use a rag. And the question I get quite often is, do you ever use a tack cloth? Do you ever use a rag, or you just blow it off? So the answer is, I pretty much blow everything off. I never use a rag. I don't use a rag for a lot of different reasons. I've got burned in the past with the tack cloth, and at the same time with rags. Rags work for a flat surface, but if you got a surface like a cabinet door that's got profiles and everything, sometimes all you do is push the dust around to the corners. So I like to use compressed air. Now, compressed air works really well underneath key conditions, and that's kind of what I want to talk to you about today. One of the biggest things with a compressed air system is moisture. Moisture in any compressed air system, and oil if you have a oil lubricated compressor. Now, this is a traditional 5 horsepower 2-stage 80-gallon compressor. It has a true 5 horsepower compressor duty motor. It's a 184T frame with an 1-inch shaft. Runs at 1725 RPMs. This pump here is actually a Sailor Beal knockoff. It's made overseas. It's a Asian-made pump. Puts out 17.5 CFMs at 175 PSI at around 760 RPMs. So it's a pretty stout pump for the most part. It's an 80-gallon tank. So right there we have the heart of the system. Now, this pump is by far not the cleanest pump. I mean, it probably has some slight oil bypass. But anytime you are compressing air in general, whether it's with a oilless compressor or oil compressor, you're taking the air, the atmospheric air, and you're compressing it, so you're pulling the moisture out of the air. And when you compress it, it creates condensation. So now you actually have water in the compressed air system. Now, most of your water is going to get caught in the receiver tank. Every receiver tank is going to have a drain on the bottom someplace. It might actually be on the side, where it actually has a little tube that runs down towards the center, and actually just the pressure of the air in the tank will push the moisture out to the drain. This one is a traditional one where it actually has a drain on the bottom. So when you compress that, you compress air with moisture. And so it's really key to keep your tank dry for a couple different reasons. Number one is you don't want that moisture migrating down your air lines to your air tools. And number two is you don't actually want it to pool in the bottom of the tank and actually start rusting out the tank and corroding it and eventually create a leak, and well, it's not good from there. So what I've done with this system here is actually invested into an automatic tank drain. Now, you can get automatic tank drains all over eBay, Amazon. I'm not going to tell you which one's the best, which one is the ideal one. I'm going to tell you which ones I have, but at the same time, just because it works for me may not be it's ideal for you. So you can buy an electric tank drain, or you can buy a pneumatic driven tank drain. Electric tank drain, you can buy them basically 120 volts, 110 volts for US, and if you're outside the US or outside of North America, you can get a 220 volt model. The thing with electronic tank drain is if you just plug them in by themselves, they constantly purge around the clock. Now, you can have them purge up to maybe every hour for like a half second, or every half hour for half a second, or however long the duration availability is on the particular model you chose. I decided to go with the pneumatic version. Basically what it does is it takes an air signal from the relief line for your bleed off for when the compressor stops. So this here is a centrifugal and load compressor. So this line here is actually what bleeds off the head pressure. Now, what you can't see down below is there's actually an 1/8-inch tap there for an 1/8-inch fitting to actually use it with the pressure switch unloader. I actually utilize that to pull a pilot line for the automatic tank drains. Now, I have 2 automatic tank drains, and the long story behind that was, I was actually testing different automatic tank drains that were available on the market and kind of giving a review on it. So I have a Conrader on the right side here, and I have a Tsunami on the left side. Now, they're both pneumatically controlled, but they work differently. The Conrader actually purges on both the start and stop cycle versus, or before and after cycle, versus the Tsunami only purges after the cycle. Is one better than the other? I couldn't tell you that. There is a price difference between the two. One is about half the cost of the other. The Conrader is actually the real version, and then Harbor Freight for a while actually had their own knockoff version. I actually tested one here. It lasted about a week. So you get what you pay for. If you buy a brand called Cast Air, they're kind of sold on the upper Midwest. They will sell you a Conrader as an entry-level automatic tank drain. This actual pump is actually branded Cast Air. Who makes it, I don't know. It is not an Eaton pump. Eaton doesn't make theirs as well. I think a lot of them are buying from one manufacturer overseas, but might have different specs. But getting back to the auto drains, I basically was pilot testing two different ones, and because they work so well, I just decided to leave them on there because they're not really costing any energy. So draining the tank, whether you do it manually or an auto drain, is going to be a plus. The more you can keep this tank dry, the drier your air is going to be. Now, that's the first step. The second step is going to be installing an oil water separator. Now, you might be wondering, what is an oil water separator? I don't have a, you might be thinking, well, I've got an oilless compressor. I don't need an oil water separator because my compressor doesn't take oil. You're right and you're wrong. Reason I say that is the oil water separator does two things. It takes all the liquids out of the air, whether it's just moisture from compressing the air, or if your compressor has a little bit of bypass, you actually have a little bit minute amount of oil in the air. Basically, it runs it through there in kind of like a centrifugal force, and your oil and water fall into the bowl and your air passes through. So oil water separator is really inexpensive. You know, if you have a professional shop, but you don't use compressed air that often, you can get by with probably an oil water separator anywhere from 30 to 50 bucks as entry level. You can spend a little bit more money and go to like a Norgreen or some of these other ones out there and spend more of an upper of $100 to $200. You do get what you pay for. But the one that I have installed is a Norgreen. It's actually got a bigger bowl, so it actually can collect more. But what I also did was, keep in mind, is it actually drains automatically as well. You can get a oil water separator with a manual drain, which is a little twist valve, or you can get with an auto drain where it actually, when it gets so much water and oil in there, a little float lifts up and it pushes the condensation out. So those are the two first things that are key to having a cleaner, drier, compressed air system. Again, it's really more so what you're willing to spend. If you use your compressor once a week for just a little bit here and there, you probably don't need to spend a lot of money. But if you use your compressor daily or weekly, you might want to think about investing a little bit more. So this is the heart of the system. Now we're going to go to the other side of the shop. I'm going to show you the last line of defense that's actually been working really well for me. But other than that, this is the compressor. Okay, so the last filter I have is in the shop here. It's actually called a coalescing filter. And what this filter does is it actually captures the last bit of any bit of migrating moisture or oil that the oil water separator didn't catch. It actually has a replaceable filter cartridge. Now, every year I check that cartridge, and I don't think I've ever seen any moisture inside the canister. But the cartridge is taking on a little bit of color, so it's catching some oil from the compressor. So definitely I'm not catching it all at the compressor with the oil water separator, but that's why I have this last filter in here. Now, if you're doing some really critical finishing where it's like automotive paints, they're going to have even more filters after that. The wood finishes, for the most part, are fairly forgiving. They're not as high-tech or not as sophisticated as a traditional catalyzed conversion varnish or a pre-cat or post-cat lacquer or nitrocellulose lacquer. And even some of the waterbornes I find aren't really as finicky as much as what you hear about automotive finishes. Now, I had never sprayed an automotive finish before, so I couldn't tell you as far as how sophisticated they are. But if you think about it, if you're having your vehicle repainted or whichever, you're going to want that finish to be nice and glassy smooth because it's going to show it to everybody. So automotive finish in general is probably a little bit more fussy when it comes to clean air. In the wood shop here in wood finishing, we can get by with a little bit more. So this coalescing filter, like I said, it has a cartridge inside it. It's designed to basically catch any particulate, any little bit of moisture or oil that's left in the air line prior to that. And like I said, it's pretty much dry, but it is taking on a little bit of color because I'm assuming there is a little bit of oil coming from the compressor yet. But that's pretty much the last line of defense, and it's a very inexpensive. If you're serious about having clean air, it's about a $100 filter. Replacement cartridge, I think it's a Parker filter. I think the replacement cartridge is around 70 bucks. Like I said, I've had it for about 4 years or so. I have a separate video on it, and every year I check it, and it's, you know, it doesn't show that it needs to be replaced yet. So yeah, it's an investment, but it's kind of minimal. So that's actually the compressed air system that I'm running here as far as how I keep the air as clean as possible here. Now, the one last thing I want to talk about briefly, which people do ask about periodically, and I do have a separate video on this, is the overnight valve. It's a solenoid valve, and that solenoid valve is actually tied in to the first set of lights in the shop here. So there's 3 bays of lights here, and the very first one actually has that solenoid valve tied to it. Now, the reason I have that is every night when I leave the shop, I automatically turn the lights off. It's the way I was raised. It's what I do. If I leave a light on, it might be a task light just because I neglected it. But when I walk out the shop door, I hit 3 switches. And by doing that, I'm actually killing the air within the shop. Now, why would you want to do that? Well, number one, my compressor is not in the shop. It's in the shop next door. So that means I'd either have to go flip the breaker or actually go turn the compressor off, which is not a bad idea. If your compressor is local, you can just buy it by turning off the compressor or closing off a valve. But what I did here was because the compressor is in a remote location, everything is soldered copper pipe up to this location, I felt pretty certain that having a fact of rupturing a copper pipe is very minimal compared to rupturing an air hose. Or on the finishing side, if I have one of my Kremlin or CA Technologies pumps plugged in, if I were to rupture a fluid hose, I'm pumping that finish all over the place, just like a garden hose spraying all over, or an air line that comes loose and just spraying all over. And by doing that, it's a hazard and it's wear and tear on your compressor. So I call it an overnight valve. Used to do it manually, but it was one of those things that you could kind of forget it. This here, it's just a no-brainer. You turn the lights out and the solenoid valve closes. So the solenoid valve is a normally closed valve. It only opens when it's energized. So anyways, that's it, guys. That's the compressed air system I'm running in the shop here as far as how I get clean air. It's really simple. Not a lot of money invested into, you know, filters or anything like that. I might have, you know, if you count an automatic tank drain, they're anywhere from $50 to $150 depending on which one you buy. A good oil water separator is about $100 to $200, and then a coalescing filter is, like I said, about another $100 to maybe $200. Now, that's more on a professional side. If you're like a DIYer or weekend woodworker, things like that, you wouldn't need all that. But what I'm going to tell you is, at a minimum, an oil water separator and drain your tank, whether you do it with an auto tank drain, electric or pneumatic, or you just drain your tank manually. There's nothing wrong with doing it manually. It's just a matter of doing it manually and remembering to do it. So anyways, hope you guys found this video helpful. Questions and positive comments are welcome. All right, guys, thanks for watching.